Let's talk about code quality, code verification. Let's talk about how we can overcome the broken Windows syndrome in .NET. That will be, the first part will be very .NET oriented, only the last third actually will be more general and platform neutral. Code verification is quite a broad scope, and we cannot cover everything just in 45 minutes. I would make a distinction between general rules and project-specific rules. So code quality is always can be summarized as controlling that the code that is handwritten corresponds or fulfills to some criteria, to some rules. And they are general rules and project-specific rules. For general rules like code style or security and performance, pitfalls and complexity metrics and so on, these are quite standard rules. So if you go to any company, you will write C# code, well, good C# code, approximately the same way. For these rules, you have a lot of standard analyzers. You have a few from, well, hundreds from Microsoft, other from JetBrains, from Sonar, from third-party open source projects. I will not cover them. I think this is pretty much covered by existing tooling. I will focus on project-specific rules. So when you work on a project, there is all this project-specific culture. It's how you decide as a team to build the project. And it's important that everybody on the team builds the code according to the same rules. However, the tooling is not as good as for the general rules, and this is what I'm going to focus on in the second part of this talk after the introduction. And in the last part, I will talk about how to manage chaos, because unless we go for a zero warning strategy, which is quite hard in a real life project, we will need to have tools to handle these hundreds or thousands of warnings, and that's what I will see. So to continue this introduction, I will spend a few minutes explaining why we should care about architecture erosion and not only about code style. Then I will show 5 tools that you can use to detect these problems of architecture erosion, and then the last part of this talk will be about tools to manage code quality. So this will be an overview. We'll look at the landscape. We will not look at any detail. Please let the questions for the end, because there is a lot of content and we will not go deeply about anything. So a few words about me. My name is Gael Fraiteur. I grew up in Belgium, in the French-speaking part. I've been residing in Czech Republic for 23 years. So I'm the founder, the creator of PostSharp that you may know, and recently I have, we have created a new project called Lama based on Roslin. So my day-to-day job is really metaprogramming and working with Roslin and so MSIL and so on. That's the only platform that I will the only product that I will talk about today where I have any financial interest is this Lama. The other projects, because not all are free and open source, I have no kind of commercial interest in these companies I will cite today. So let's talk about architecture erosion. How does it happen? What does it mean? So typically in the beginning of a large project, you would have an activity that we call architecture. So senior developers, architects meet and they draw on paper, they write text about how the software should be written. So they write a set of rules, they write diagrams, so class diagrams, dependency diagrams, naming conventions, they select patterns of how the software should be then programmed by the development team. And it's a matter of role, it's not really a matter of person or job title, it is a matter of which hat. And it's important that this hat of architecture is performed in the beginning of the project. So we get a set of rules, but these rules are text and diagrams, they are not executable. So during the implementation of the product, developers write code and we need to verify that this code respects the original intent, the original architecture. This is traditionally done during code reviews, which may happen a couple of days after the last commit. There is a lot of friction according to that. And sometimes, when there is a petty, a little violation of naming convention, you probably don't want to send the PR back just for a small cause. And so because of that, the quality of the code base compared to the original architecture, it may erode progressively. So we have this broken window syndrome, like if my colleague didn't respect this rule, why should I? So this is a progressive process, but it has some consequences. There is another process that we talk less about. When we have architectural defects in a code base and all developers build the software according to the rules, well, it works when you have any generative process that follows rules, like building a wall out of bricks of the same size. You are following the same pattern. If you introduce a defect inside this system and you continue building according to the good rules, well, even without the broken window syndrome, you are going to amplify this defect in your complete code base. And I can see that practically quite often when I allow for a hack in the code base, if I come back 6 months, 1 year later, it's much harder to remove the hack because developers built on the hack and assume that the hack was a part of the desired architecture. So we have the broken window syndrome, but we also have this castle syndrome, according to the name of this exhibition by this artist, Jorge Mendes Blake, if I pronounce properly, probably not. So it does make sense to spend time and energy to fight against architecture erosion because it costs you something. The biggest effect of architecture erosion is that the complexity of your code base raises. So what's the complexity here? I'm reasoning about complexity as in information theory. It is the amount of unique bits you need in your brains to fit the code base. So suppose that you have a large code base with hundreds of forms and thousands of properties, but they all follow the same pattern. Well, maybe that the code base, despite being large, can be simple because the number of rules it follows is small. But in information theory, every exception to a rule is a rule in itself. This is a bit of information. So the information, the amount of information that every developer on the team needs to fit in the brain is actually this complexity. And this is why I consider personally complexity as the major factor, metric to take into account when designing software. And from this problem of excessive complexity, you get all the other ones like lower productivity, more bugs, and poor maintainability, which means that it is more difficult to create a new version. So I'm switching to section 2, where I will show 5 tools, 5 approaches to detect architecture erosion. I will talk about architecture unit test with an open source framework. I will show how to do a simple command line verifier. I will do a very brief introduction to Roslin analyzers. I will talk about Lama. I will talk about NDepend. That's my second section, and then the last section will be about how to manage all the warnings we are going to generate. And let's move to architectural unit test. I will show a framework, an open source framework called Arc Unit Test, and the principle, the concept of Arc Unit Test is that you will write architectural unit test. So it's a framework where every unit test validates one architectural rule. The way it works is that it loads compiled assembly. So first you will build your project. It will So the test framework will load your binary assembly, decompile it using monosysl, and then run the tests that you define. I will switch to my virtual machine. And before I go into Arc unit test, I will show you the code base that I would like to validate. It's very simple. It's done specifically for this talk. So we have an namespace abstraction with here an interface, another interface. Here you see I have something that is ugly. This is a violation because the abstractions namespace should not reference an implementation namespace. So here is one violation. I have a rule in my head, but it's not implemented yet, that factories must be named factories. And here I see, well, this factory is actually a factory, but it is not named factory. So that's bad. I have another rule that I would like to enforce, that all implementations of iDocument must be in this namespace document. Well, this file is not in the right directory or namespace at least. So let's see how we can do that. To make an Arc unit test project, you would start creating a normal XUnit project. The only difference is that you would add a reference to a package reference to Arc unit test. This is the first thing to do. And then you reference the code that you want to test, as in any test. Then you create a test class, very classic. The next step is that you define in a field, typically this is done in a field, you define the set of assemblies that you want to verify. Once you are done with that, you create one test method for every rule that you would like to enforce. Let's read the first rule. So we take type that implement iDocument factory. These classes should have a name that matches the regular expression, factory. And we check this for the set of assemblies that we defined. You see, it's all very natural. It all fits the concept, like Fluent API. Let's take another test. The types that implement this interface must be in this namespace. And then this time, types that reside in the abstraction namespace should not depend on any type that does not reside in the abstraction namespace. So you get the idea how you can create unit tests for your architecture. When you run the unit test, you will get errors like this. The thing I like is that it's able to generate very, very nice error messages. So every rule so every broken rule is going to result into a failed test. So the thing I like about Arc unit test is that it's free, it's simple, and it is familiar. It's integrated in the testing paradigm, which is okay. The thing I don't like is that it doesn't sound like a warning or an error. It doesn't sound native like a C# warning. And also these are errors and not warnings. So if you have a violation, you automatically have a failed test. So you cannot easily say, let's make an exception to this rule and skip this. Also, there is no source code link, so it's maybe a minor factor, but you cannot double click on the test and see where the problem is. So if you go for a zero warning strategy, that's actually quite a good solution. Okay, second approach would be to create your own command line verifier. So don't use system reflection because it doesn't give you access to references. If you validate architecture, you will most likely want to reference dependencies between namespaces, class, and so on. System reflection doesn't give you that. You can use monosysl. It's quite a low-level library. I don't know if there is higher level components. I wrote too complex. Maybe these components exist. I don't know them. Don't use Roslin. It doesn't make sense in a command line verifier because it is very complex. And if you use Roslin, rather do an analyzer is going to be my third example. You can use a free library that we build. It's called Lama Framework Workspaces. And this is quite straightforward. No, it's not this one. It is this one. So this is a console program, console program. I add a reference to Lama Framework workspaces. I have now a bunch of other packages. I think that in the latest version you don't need them, but you still need them here. And the rest is just a program. So this program takes an argument, which is the SLN file or the CSproj file, the full path to that. You load this into a workspace, and then you can do code queries. So we select types that have, well, the type, this interface type, we get all the derived types, then we verify that these types, their name ends with the word factory. If they don't, we report an error, and this is how we are doing all the three rules. The MetaLama model, this is where it is useful compared to, say, Roslin or Reflection, is that you can get a list of references that you can browse and validate every reference in your project. So the benefit of this is that it's very simple. You can just run the program. If I run this program in Visual Studio Code, it's actually quite easy. I can control-click the error messages, and I come immediately to the location where I have the problem. So there is a kind of basic integration. So that's completely free. It's quite simple. No, now I'm lost with my switching desktop. Yes, from current slide. Oh no, I got this sickness of the mouse pointer that it disappears. It's back. Okay, so now if you want real integration and you want this real-time analysis and the squiggles and all these things, then you need to look into Roslin analyzers. So Roslin analyzers, they are one of the five official extension points of Roslin, and they execute both at design time within the editor and at compile time. The same code runs, and so it gives the user, that means the developers that will use this, a very familiar experience. You have access to everything the C# compiler knows about your code, so you can do everything. The problem is that it can be complex. But I will show you one example. I will implement one rule, and this one is quite simple. Step one, you create a project, and it must be .NET Standard 2 because this code will run inside Visual Studio. And in some cases, Visual Studio still run .NET Framework. It's a bit complex architecture, but in some cases, it will still need to run under .NET Standard 2. Then you add a package reference to Roslin, so Microsoft Code Analysis C# will give you anything you need. I like to use polyfills. It allows me to use the latest C# with the latest C#. It allows me to use the latest C# version with .NET Standard 2. This is entirely up to you if you use it or not. So step one, create the project. Step two, create a class. It must derive from diagnostic analyzer. It must have this custom attribute, diagnostic analyzer. Then you define a diagnostic descriptor, which is the metadata about all the warnings and errors that you will maybe report. You define it here, you expose that into this property of supported diagnostics. And then the entry point of your class is this initialize method, and the most important thing to do is to register an action. So you have many possibilities, but here for this, I will register an action that will analyze a symbol. A symbol is something that is already analyzed. I mean that it's a method, for instance, but it's not the text of the method. It is the concept of the method. So here I will validate named types. That means all types that have a name, delegates, interfaces, class, structs, records, not arrays. So I have the context here of the symbol. I cast it to a name type. I check if it does not end with factory, but it does implement an interface that is named iDocument factory. Then I'm going to iterate all references. There may be many. If your class is partial, you are going to have many syntax references. I get the syntax behind this reference, and I report a diagnostic with the diagnostic that I defined before. So all your analyzers are going to have the same structure. Typically, assemblies that have analyzers have dozens of analyzers in the same assembly. So you typically don't do a big analyzer that reports many errors. Typically, you create one analyzer per message that you report. So the next step is to use the analyzer, and you will add a project reference to the analyzer project, but it's not the standard reference. You need to say that the output item type is analyzer, and that you do not want to reference the output this project in your output assembly. So to make sure that the project doesn't flow, the DLL doesn't flow to your compiled assembly. So once you have this in place, you can check, what did I do? I think I did the naming convention. So the naming convention, you can see here, my analyzer warning. So this is exactly the warning that I defined in the analyzer project. So that's how analyzers work. This case was simple. The problem is that it can scale pretty badly in complexity. But you get the benefits of having exactly the same look and feel, the same experience, and CI integration. Everything works just as normal C# warnings or errors. You have these sharp pragma warning disable will work, warn as error will work. It will be ingested in the Sonar, Kodana, and so on. So when to do that? So in my opinion, it all depends on the complexity of the validation that you need to do. If you build APIs for customers and you have hundreds of or thousands of developers using your APIs, then it does make sense to write analyzers. If you are on the architecture team of a larger team with dozens of people, it does make sense to invest. Probably for smaller projects, it may become too complex. For these projects where doing analysis is too complex, we built Lama. It's a meta-programming framework where code generation is not the first activity. The first pillar is code generation. But because we have all this architecture, all this infrastructure to cope with code, we can also do code validation. So it's based on Roslin, so we can have all the benefits of Roslin, except the one of being signed and certified by Microsoft, of course. A big benefit in the Microsoft ecosystem. But it is simpler. Let me show you. I will briefly show you the code generation ability, so you get a better idea of what the core of the product is doing. Typically, you would write. This is the Hello World example where you have a code template. So this is a logging code template, and this code is like meta programming. So this will be replaced by the method signature string. So if I apply this here, well, actually, if I run the code, it's going to is going to run the code plus the template expanded. So all this template expansion happens at build time, but I can do the preview here. And we can do more complex things like generating notify property change. In this case, not a good example here, but it would generate any repetitive code. So that's the first pillar. And the second pillar of the product is code generation. And here code validation. There are two approaches. One approach is to use custom attributes. So for instance, for the naming convention, instead of like creating your own analyzer, you can use this custom attribute. Derived types must respect naming conventions. And now if I go to the violation here, I believe, yes, here, you can see that there is a warning that this class does not respect the naming convention. One of the differences with Roslin analyzers is that you don't need a separate project. Another way how to express constraints is to use what we call fabrics, and these are classes that execute at compile time or at design time within the IDE or within the compiler, and you can express things like add aspects to all these namespace, like logging all public methods or so on, or you can express things like the code quality namespace cannot be used from the documents namespace cannot be used from the abstraction namespace. This package that I'm using, Lama extensions architecture, is open source. You can see how it's built, and you can build your own rules. So you have a set of ready-made rules that cover many needs, but if for some reasons this is missing, you can go to the next level. It is shown here, where you will find a similar architecture that you define warning metadata. Then you say which references you want to validate, and then you validate the reference. If you don't like the reference, you report an error. So that's another way. So there is a free version, there is a commercial version. The free version would support custom attributes, not fabrics. There is a fifth tool, and I think it's very important to code quality, and it has been there forever too. Ndepend. This is a kind of Swiss Army knife for code quality and code verifications in .NET. There is a strong focus on user interface. You can use the UI to validate not to validate, but to visualize your code base. So let me switch again. Here, Ndepend comes in different flavors. One is a standalone UI app that you can just unzip and run. Another is a command line runner that will generate the reports and tell you if there are errors or not. And the third way is a Visual Studio extension. So there is a UI. You can go here. You go to the first thing you would do to understand the project is to go to the dependency graph. This is why it is called Ndepend. And immediately you see that there is a problem here because it's red. Red means there is a problem. And now if you dig in here, you will see it will write that there is a cyclic dependency between two namespaces, which is a default rule with Ndepend. It doesn't like it. So there are a lot of architecture rules having pre-coded. But for this talk, I always want to do the same 3 rules. And here is how you can do architecture rules, so custom architecture rules in Ndepend. You go to the Rule Explorer, you can create custom rules. They are here. And here is the first one. You can see it's pretty simple too. It starts with warn if. It can be error if or warn if. Warn if there is more than one type that implements the iDocument factory interface, but is not named factory. So this is how a rule in ndepend would look like. And because there is one violation here, you can see in which class you had violation. You can double click to the class. It would open the file. So this is the interactive way of looking at things. Typically, you would integrate ndepend to your CI pipeline, and it would generate a report. I'll show you the report here. So here is a report that you would generate during a CI build, and it would be then stored as a build artifact. You can see which issues are in the project, which files, and the rules that have problems. That's quite a complex tool. So it's a tool for architects, and I would expect the architect to spend a couple of hours learning everything, maybe even a day or two. It's really a complex tool. So what it can do is this, visualization of architecture and dependency graphs. It can do the custom rules, CI integration. Thanks to custom rules, you can do architecture verification, but it's not the core objective of the software. It is .NET only, and that will be a difference with the next section. So here, I will assume that we have these analyzers that generates warnings, and currently this works with anything that is able to generate Roslin warnings. That means the Roslin analyzers and MetaLama can generate warnings. But if you have hundreds of those warnings, then how do you cope with them? That's the next part, and this becomes a management problem. This is no longer a coding issue when you need to, when you have one error to solve. It is a coding issue when you have 1,000 of warnings to solve. It becomes a management issue. So I will talk about 3 strategies, and the first strategy, of course, is to say 0 warning, because then if you have this strategy, well, there is no question about having hundreds of warnings. That's what we do, but we don't do that in local builds. So I would not recommend doing that in development builds on development computers, because then you cannot even do a debug, like run the debugger without having your code formatting done properly. So what we do is to have this condition here that CI builds treat warnings as errors and local builds are not. Also, we have internally different severities of warnings, where we have a higher requirement for releases than for PR. So we do more cleanup at the end of the release than we do for every single PR. But if you want another strategy than 0 warning, you will need to go for a tool. I've talked about ndepend. It's a bit a separate product because it is not a service. Kodana and Sonar are 2 similar and competing products, and they can be compared as a kind of online database of warnings. So you would set up the service. That's the first step. You go to Sonar, you go to JetBrains, you create an account, and you get a token, and then you add a step to your CI pipeline to analyze the code. And I will switch again to my virtual machine here and show how it is done. So as an example, I took integration with GitHub Actions. Here is the code required by Kodana. It's 1 step. This step will fail, or it will succeed. I will show later how you can set conditions. For Sonar, it is a bit more complex because you need to install Java. But basically, once this pipeline is set, it is very similar. So that's the first step. And then once this is in place, it's going to upload the warnings. So quality reports are going to be uploaded every time you run this GitHub action. So this tool gives you several features that you can use. One is a time view, so you can see if your code quality is increasing or decreasing. So you have this time axis. Here is a very small project, but you can see that in the beginning when I set up the project, I had 30 issues. And then I realized I didn't want to have code style, so I reconfigured that. You can see that the tools, and Sonar does the same, the tools show up the breakdown of errors by category and by severity. Both tools do the same thing. So once you have these tools in place, you can implement more quality strategies. One quality strategy is quality from now, and this is when you take under your wings, you take a code base that has hundreds or thousands of warnings, but you set up a policy that we are not going to add more warnings. So what you can do is to define a baseline, and the baseline is a set of warnings or instances of warnings. You know, it's not the same as ignoring all instances of a warning ID. This is one warning on one line of code that you can add to the baseline, and then it is ignored. So here, if I take this build, you can see that I have one problem, which is my architecture problem here. One problem that I must solve because it is not in my baseline, but I have one problem in the baseline that somehow I decided I will not solve. So that's important because this feature allows you to start quality from today and to go to an improvement path, even if now you are in a bad situation with thousands of warnings. And this is actually what these tools are about. So in Kodana, if you want to add a warning to the baseline, you would click here, you would do move to the baseline. It's going to generate a file that you need to upload to your Git repo, and that is going to be your baseline, which I'm not sure where it is actually. Yes, I've put it in this Kodana directory, and so this is my baseline file that is generated from the UI. So we have a second strategy, which is baseline quality from now. All tools do that, and Depend do that too, except that there is not this server interface. The third strategy for quality that these tools offer, all three, is that you can define quality gates. So if you do zero warning, the quality gate is to have zero warning or fail. But quality gates in these tools can be more complex. You can define thresholds. You can say, for instance, that the build will fail if there is one security issue, but it will succeed unless there are more than 500 normal warnings, for instance. So you have these tools that may make your build fail or succeed. In Kodana, you can configure that in this XAML file. This is how you configure Kodana, mostly here. And they are called the failure conditions in Kodana. In other products, it may be called quality gates. And here I've set zero critical, 0 high, and 100 moderate. So it's up to you if you use this approach. I find it a bit dangerous because suppose that on Monday my colleague merged 20 issues, and then I come with one issue and I'm blamed of crossing the threshold. That becomes more a management issue and a people issue than a technical one. Other things that these products offer are the quality gates based on code coverage and based on license audit. That's another feature they use. So Sonar and Kodana have very similar benefits. One is that they come with a large number of ready-made analyzers or linters. That means that for all these general rules, well, your job is to disable the warnings, the warning types that you don't want, because there are so many of those. So that's well done in all these products. These tools give you the products give you the real tools to manage these thousands of warnings. This is their reason of being. They are all multi-languages except NDepend, and JetBrains tools integrate very well with JetBrains IDE. You can go to in their portal. You can go to the warning, and you click on edit. It will open right there. This is very nice. So the disadvantages I can see is that it's one more service that you will need to operate and to pay for. They don't have built-in support for architectural rules, so you still need to use anything that is Roslin compatible. So Roslin analyzers or MetaLama are the two tools that would allow you to ingest warnings into their management system. And so as a conclusion, these platforms are useful for technical debt management when you have hundreds, thousands of warnings and you want to do something with that. So it's time for conclusions, and then it will be time for questions. Code quality is not just about code style. No, I skipped this part. There are so many ready-made rules and analyzers for code style that I think this problem has been solved. It's just now a practical problem of applying those tools. I've shown 5 different approaches to architectural enforcement. One of the key differences is, does it allow for warnings, or is it error only? That's a major difference. Is it real time, or is it build time only, or a CI step? So these are the major differences or differentiators. Also how simple or complex this is. Now, and once you have warnings, then you need another set of tools to manage these hundreds of warnings, unless you go for a zero warning strategy. Basically, you have the choice between Sonar and Kodana at this moment. Maybe wrong, but I think these are the 2 big players. Kodana is much younger. Sonar is much more mature. And I think that's the major difference between both. Thank you very much.